Good morning. Welcome to day number 13. I've already heard from people this was a hard one, so let's let's dive in. So today, little special announcement. I've been complaining about being tired for basically every day of this challenge, and we finally have told everybody we're having a baby. Throw the ultrasound up on the screen so you can see it. Yeah, we're pretty excited. So anyway, just a small little personal update. Like and subscribe for babies, I guess. I don't know. Into the problem. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs from the seaport at timestamps 0, 5, 10, and 15, and so on. The bus with ID 11 departs at 0, 11, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Your notes, which is your puzzle input, consists of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. For example, suppose you have the following notes: 939, 73XX, 59X, 3119. The earliest timestamp you could depart is 939. The earliest timestamp you could depart is 939, and the bus IDs in service are 7, 13, 59, 31, and 19. Near timestamp 939, these bus IDs depart at the times marked. Okay. So here's 939, and I'm guessing we're supposed to pick this one because it's the closest to 939. The earliest bus you could take is bus ID 59. It doesn't depart until timestamp 944, so you would need to wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you would need to wait gives you 295. What is the ID of the earliest bus you can take to the airport multiplied by the number of minutes you'll wait for this bus? Okay. So 931 divided by 7 is 133, so 133 iterations. I'm just looking, surely there's a pattern here, and we're not just supposed to calculate every possible number until we go over. I mean, maybe we are. 939 mod 7, 939 mod 7 is 1. 939 mod 13 is 3. 1, 2, 3. Okay. Mod 59 gets us 54, which is 1, 2, 3, 0, 1, 2, 3, 4, I guess. Weird. Okay. 31 is 9. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you can use mod to figure out the one that we just missed. What's 939 mod 7? That's 1. 1, 2, 3, 4, 5, 6, 7. So the one after it would be 939 mod 7 plus 7, so it'd be 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Minus 1, I guess. So it'd be 7. 1, 2, 3, 4, 5, 6, 7. I guess maybe like even like minus 2. That's like super weird. But like, I guess maybe that works. Let's see how this pans out for bus number 13. 8. 1, 2, 3, 4, 5, 6, 7, 8. No. Oh, mod 13 is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's not minus 2 because that was like maybe this right here. So this one would have to be like minus 4, I guess, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's something like that. You can kind of just math your way through this, I think. So let's see here. So can we turn 939 and 7 into 945? Let's try that really quick here. 7. What does that get us to? That gets us to 1. So it was 1 minute previous. And then we go plus 7, which is 8. So let's do, hold on, let's do 939. Let's do 939 minus 7, or minus 939 mod 7, I think, which would be 938, and then go plus 7, gets us to 945. Okay. And then whichever one gets us the smallest number wins. I mean, maybe. That seems pretty reasonable. Let's try it. Next arrival time equals that. Okay, so let's play with the sample input. I don't even know if I even care to parse this sample input, honestly. Let start time equals 939, and then maybe I just parse this right here, right? So then what I can do is I can say let bus times equals input.ns.components separated by a comma dot compact map to an integer. Let's try that. That should give us all the bus times, but drop the x's because those aren't converted to numbers. In case you weren't from here for the previous episodes, this is an extension I made that just quickly converts string to NS string because I just do it so often. Okay. And then what we can do is we can say for time, well, we want the min equal, min time equals int.max, I guess, and var min bus equals int.max. I don't know, I'm just picking a random number. For time in bus times, so we're going to go through every bus time, and we're going to say, the next arrival is start time mod time, the bus time, plus time, so that'll give us the next arrival. We're going to print time next arrival time, and then we're going to say if next arrival time is less than min time, then min time equals next arrival time, and min bus equals time, I guess. And then we're going to, at the very end, print time. Print time and, min time and min bus. Okay. Let's see if that prints out accurate numbers for all the things. I think that feels. Let's see. Let's compare it to this here. So the 7 comes at 9:45. The 13, the next one that comes, is at 9:49. The 59 comes at 9:44. The 31 comes at 9:50, so it's completely off the thing. And the 19 comes at 59, which is off the thing. So the best one it picked was the 59, because that's it. Okay. Let's try it with our puzzle input, shall we? Okay, so let's cut that and try that. Let's try with our puzzle input. For the 467, is that it's like one of the first ones? Sorry, we want let's see, the earliest time you could take, so it doesn't depart until timestamp 9:44. So you would need, okay, hold on really quick. I did not get the output correct. I want the correct output. Okay, so what you need is 5 minutes. So let's run this again really quick with the old input. So what we actually want is we want min time minus start time. And then what else do we want? Just 5 minutes before it departs, multiplying by the bus ID. Okay. Times the bus ID, and then I'm gonna print the min time here just for my own sanity. So the answer is 295. 295. Okay. Let's try this again. With our full input. 164 is the answer, it says. Not right. Your answer is too low. 164 is too low. Okay. 164 is too low. Okay, is there anything about this input that's weird? Oh, I did not update the start time. Dum 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 dum. Let's try that now. 3269. 3269 is the new answer. Gotta wait 16 seconds. Okay. 3269. 69. This is the problem. I always forget stuff like that, and that throws me off. It's almost, it might, like if this doesn't work this time, just to save myself from accidentally submitting the wrong thing again, I might just, okay, it worked. Never mind, we're good. Okay, part 2. The shuttle company is running a contest, 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time. Wait. The shuttle company is running a contest, 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus ID departs at that subsequent minute. The first line in your input is no longer relevant. For example, suppose you have this. An X in the schedule means there are no constraints on what bus IDs must depart at that time. This means you are looking for the earliest timestamp such that bus ID 7 departs at timestamp T. Bus ID 13 departs 1 minute after timestamp T. There are no requirements or restrictions on departures. There are no requirements or restrictions on departures at 2 or 3 minutes after timestamp T. Oh, okay. So the 13 is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes. Departs 4 minutes, yeah. 1, 2, 3, 4. Departs 4 minutes after timestamp T. There are no requirements. Okay. At 5 minutes after timestamp T, and 31 departs 6 minutes after timestamp T. The only bus departures that matter are the listed bus IDs at their specific offset from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. For example, in the list above, because bus ID 19 must depart 7 minutes after the timestamp at which bus ID 7 departs, bus ID 7 will always also be departing with bus ID 19 at 7 minutes after timestamp T. In this example, the earliest timestamp at which this occurs is this. 1 minute after, 4 minutes after, 5 minutes after, 6 minutes after, or 1, 5, 6, 7, is that what it is? 1, 2, 3, 4, 5, 6, 7. Okay, 1, 4, 6, 7. So 1, 4, oh yeah, there's a gap there, 6, 7. Is what we're trying to figure out. The earliest timestamp is this one. That's the one where it finally happens. In the above example, bus ID 7 departs 7 minutes after T. In the example above, bus ID 7 departs at timestamp 1068788. This is fine. The only requirement on that minute is the bus ID 19, and it does. Oh, they're just saying that like it's not a problem because both of these leave at the same time because of how they happen to line up. Okay, here are some other examples. However, with so many bus IDs in your list, surely the actual earliest timestamp will be larger than a bajillion. What is the earliest? So we learned from our last time that you can't just brute force something like this. Like there is a pattern of some kind. So the question is, how do we calculate the moment at which Like, how do we generate this is the question. So what we're trying to generate is based on 7, 13, and 1. Okay, interjecting here from the future. You'll get to the point later where I give up. Let's talk about why the solution kind of went wrong here, and sort of, again, pulling up a spreadsheet so you can kind of see how it works. So this is our input here, if you want to verify. So 7, 13, x, 5, 9, x, 3, 1, 19. Cool. So what that kind of translates to is 7, 13, and then there's no train running here. There's no train running here, but this grows the number of minutes. These are basically empty minutes, right? So 59, 31, and 19. So the reason why we're picking 1 is because 59 mod 1 is always 0, right? You can pick any number you want here, and there's never a remainder when you divide by 1. So that's useful. So now the question is, how do we know if it was just 2 trains, if it was just a 7 and a 13-minute train, how would we know which one to pick? Like, what number, if we went down the list, what number would we hit? Well, the answer is pretty simple. It is, we need some multiple of 7 that when you add 1 to it and then divide it by 13 still equals 0. Let's explain that. Let's break that down. If it was just 1 train, it would be 7 plus 0 mod 7. So it'd just be that first train. But for it to be 13, if we look at the sample over here, if we look at the 13, you can see that it needs to come 1 minute later. So let's go back over to our spreadsheet. We don't need all these open anymore. So the 13 needs to come 1 minute later. That means that for it to be a match, it needs to be whatever time we counted up to this plus 1 minute later. And then to know that it's a perfect match, you do the modulo. That we learned that from part 1. This has been sort of the crux of our whole thing, is how do you find the number that when you do modulo equals 0? So what you do is you just keep counting up. So 7 plus 1 mod 13 is not 0. And you keep doing that until you hit 77. 77 plus 1 is 78. Mod 13 is 0. So 78 mod 13 is 0. So that's how you find the first number. So let's look at this. So our current time, we're going to start at 7. We're going to count up by 7. And then what we do as we're counting up by 7, and we're gonna look at not all the numbers, but I'm gonna start at 0. We're gonna look at the buses that come after. So in this case, current bus is 13. So we have the time is 7, we're growing by 7, and the bus that we're trying to match is bus number 13. So what happens is 7 plus 1 divided by 13 does not equal 0. Well, okay, let's add 7 more to it. And we do that, we do that, we do that until we eventually hit 77 plus 1 divided by 13 does equal 0. Now this is the part that is weird. The time increment, we grew by 7 before, but we can't grow by 7 forever because we need all the next numbers to always be divisible by 13. Well, a really good way to do that is you multiply 7 by 13. So in this case, 7 by 13 is 91. That's the new number we're going to be growing by. And so if you go 78 plus 91, that gets you 169. So that's what we're growing by. And that number is dividable by 7 plus 1, because we are offset by 1, and 13 exactly. That's really weird to think about, that we need it to be divisible by 7 plus 1. or 7, did I do that right? Divided by 7? Or divided by, or moddable by 8. All right, sorry, not 7 plus 1. See, even now, like, I'm still not thinking through this perfectly straight. It doesn't need to be 7 plus 1. It is 7. The modulus needs to be 1. It needs to be off by 1. It needs to have a remainder of 1. That's a really weird solution. This part right here, I don't know that I would have ever gotten this if I was doing it by hand, no help. I don't think I would have ever gotten this unless I literally wrote down all the numbers that matched on paper and did it with some like smaller numbers and just did it until a pattern popped out and said, oh, okay, like I can see here that, you know, the number is, it needs to grow by this. That's a hard problem. Now, if you want to read more about it, so this is Derek, C.A. Derek. His Advent of Code Day 2020 solution. And he points out that this is known as, or this is Chinese remainder theorem. And the reason why it works is because the numbers that they give us in our solution are prime to each other, which is, again, like, unless you've done number theory stuff, I don't know how you would recognize something like that. So problems like this, if you didn't solve it, don't get too discouraged. I didn't get it either. I'm not familiar enough with number theorem. Could I eventually have gotten it? Yeah, I wrote a brute force solution that would solve it eventually. It just took ages. So the question is then, like, how would I have solved it? I think that it really would have been just, okay, we're going to count literally every number. We're going to pick some smaller numbers so it's easier to count and see if I can pick out the pattern. That would have been it. That's kind of brutal. Anyway, so running this now is now much faster, but we do actually get the real solution, which is nice. I don't even need all the prints. Okay. Hopefully you found that useful. Like and subscribe the whole bit. I'm now going to let the full solution play. So if you actually want to see all the different things that I try, actually looking up on Reddit and finding out these sort of suggestions and solutions and how they fit into number theory, I'm going to play all of that as well now. Hopefully you guys enjoy this one. This was a really tough one. We'll catch you tomorrow. We're supposed to get this. Okay, so some equation eventually equals this, and the numbers that we have to work with are 7, 13, and 1. Okay, let's just play a game here, and let's go like this. Mod 7 is 0, mod 13 is 12. It's 1 off. Okay, so is there a operation that's the inverse of mod? That feels like a dumb question, but maybe it's not. Because basically what this is giving us, so this minus 13 equals 1, right? Let's make sure I understand that correctly, but I think that's right. Equals -1. Let's do it the other way then, so we don't have to deal with negatives. So like that. Okay, equals 1. And then if we do the same thing for 7, it equals 7. Okay, so this part was helpful, 0. I mean, I guess I can just do a switch, right? Like if equation equals 0, done, I guess, and then else do this part down here. Okay, let's see how this equation plays with the other numbers really quick that they gave in the example. But then I need to try to invert it somehow. $13, so let's go 59 and 59 is 4. 1, 2, 3, 4. Okay, so this appears to work okay for those numbers. Let's go 31. I think this one's supposed to be 6. Yep, 31 is 6. And then 19 is 7. And 19 7. Okay, so that equation works for everything except for we're mod 0. So the question is, for this equals y, where this is x, x. So this would be what? X minus y. I'm swapping these two over. Equals 1068781 mod x. Inverse of mod. Yeah, what's the inverse of mod? The modular multiplicative inverse. The modular multiplicative inverse of an integer, modulo m, is an integer b such that ab equals 1 mod m. I mean, be noted that a to the negative 1, or the fact that the inverse is implicit, okay, whatever. Multiplicative inverse of a modulo m exists if and only if a and m are co-prime, calculate a times b mod c. The modular inverse of a mod c is, yeah, I know that. I know what it is I'm looking for. I want to know how to calculate it. Oh, is this like a cryptography thing? I typed calculator. I typed modular multiplicative inverse. In mathematics, particularly in the area of number theory, a modular multiplicative inverse of an integer is an integer such that the product ax is congruent to 1. This is so far out of my depth with math stuffs. Modular inverse code, inverse of modular. Will this website actually tell me? Given two integers a and m, find modular multiplicative inverse of a. A equals mod inverse of a and m. A equals a mod m. And then they try them all. Well, that's stupid. Is there really no other way besides trying them all? I mean, maybe that's right, and that's why this problem's interesting. Like, this is a cryptography style question, is that there isn't a good way to calculate it. Huh. Okay. So that's like the crux of it, is there is no inverse to that operation. Interesting. Wow. Okay. Is there any other, so are there any other properties about these that like are maybe useful, right? So like I can't do that, but like it gave a pretty strong hint that like I shouldn't go that route. So what is like this divided by 7? Blah. Okay, I'm gonna delete this before I confuse myself with it. Okay, divided by 7, take 152,000 operations. I guess I can do, I guess technically, you don't need to check every number. You can advance in increments of your lowest number, right? So you start with 7. Okay. Let's see. Minutes after time is an integer, and bus ID is an integer. It returns an integer. So I guess what we want is basically this, right? So if, and it's just this right here. So let mod value remainder, let remainder equal time mod bus ID. Okay, and then we're going to say if remainder equals 0, return 0, else return bus ID minus remainder. I think that's what we want. Let's try that for each of our things, and we'll just do, I don't know, like 10, 100. Actually, what's the little, they give us a little diagram here. For I in that ... to that, and then on each loop we're going to do for time in bus times, and then we're going to print minutes after I, and I'm going to save myself bus ID. Call that bus ID. I'm going to save myself a bug later. Print that, and then print star, 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 star. Nope. Nope. Okay. And print that. So let's do a bunch of these really quick, and let's just make sure that all of this lines up. Okay, so at this time, I do not need this anymore. Okay. So at this time, 9:15. These like in inverse order. What is happening? Okay, this is not making it any easier. I space and then string plus equals string plus equals minutes after time, or I and plus ID, and then we're just going to print string. That'll be easy to read. Dang it. And a comma and a space, I guess. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do we have 9 numbers? Do we have 9 bus times? We don't have 9 bus times. Oh, I'm still operating on my big input. That's interesting that there's only 9 bus times to actually calculate. That's nice. Okay, let's try that again. It's like, this is weird. Okay. So 1 minute to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, how did I miscount that? I don't know. 12, 13, 14, 15. Okay, so that looks like it accurately is counting. So at 1, 0, let's see, the one that ends in 88, it's a 0. Okay. So that's easy enough. So what we need to do then is we need to change the way we parse this. I mean, I could, if I'm just gonna be lazy here, do I get the element, which is fine. Okay, I guess what I can do here for part 2 is I can say bus times equals this. Actually, I'm going to put it in a function again so I don't mess myself up. Bus time, or part 2, bus input, which is an array of strings. So what I'm going to do is I'm going to take I'm going to change this back to a let. I'm going to take this part, because we still want the parsing. And then I'm going to take this part. do this. I guess I don't even need to, I'll just reparse it. It's fine. I'll just reparse it. Okay. So strings is that, but bus times is going to actually be an array of int and optional int. No, an array of int. Oh, that's going to be error prone, huh? Okay, so for string in strings dot enumerated, let index equals string dot offset, and if let int equals int from string dot element, then so basically what we're doing is we're building up an array that tells us the index and this is the bus ID. So basically it's doing the same thing, but it's storing the index because we need the index, because the index tells us the offset. So for example, index 0 is 0 minutes, index 1 is 1, and so on. Okay, so that's a good start. Now, is there another way? Well, I'm gonna be dumb and I'm gonna try the brute force method first, since we only have like 7 things to calculate, and it should be able to calculate them pretty easily. Okay, so then the next thing we're gonna do is we're gonna say, okay, let's first bus. Oh, should we sort these? No, it's the bus times are in order, so it doesn't matter if it's the smallest bus. Is our first bus big? 13. That's okay, I guess. Let first bus equals bus times dot first, and then what we're going to do is we're going to say for I in 1 dot dot less than bus times dot count. So this will calculate each bus. We want to say while true, we're going to loop forever, I guess. Forever, check all the bus times. For current time equals first bus dot. See, this is why. Let's see, we want index bus ID. Current time equals 0. I mean, I guess it could show up on the first one, but it probably won't. Current time equals that, and so then what we actually don't need the bus ID for the first one, right? No, we do. That's how often it increments. So current time equals 0, and we're gonna say do some math, and then dang, magic mouse, always disconnecting. So we're gonna check this time to see if it meets the parameters, and then we're gonna say if not, var worked equals false. If it worked, then we're going to break, and if it didn't work, else, then we're going to continue, but we're going to current time plus equals bus ID. I'm going to change this to be first bus ID because I probably actually want to use the variable bus ID at some point. And then what do we print? We print the current time. That's not what it wants from us. What is the earliest time such that all the listed bus IDs depart at offsets matching the positions of the list? Okay, so we're going to print current time. Okay, so then what we're going to do is we're going to say if, let's see, let's let bus index and bus ID equals bus times sub I. Okay, if minutes after current time and bus ID equals index, then we're good. So if they don't equal each other, then continue, then break. Don't look at it anymore. If it worked is true, and so as soon as we find one that does not work, which is going to be the most common case, then break. Whoops. Okay, I think that will work. In their example they gave, they start it right here and it only takes a few iterations. I'm going to do that. Nope, that's not what I want to copy this. Let's start here and let's do it with their sample input and then see if we get the correct current time, and we'll try it with a couple other sample inputs. What did I screw up? Invalid redirect declaration. Whoops, file private. Okay, let's try that. Okay, so part 2 ends at part 2 ends at 3327596. What? Is it still going? It's not still going, right? Oh, this is going to be a problem. Yeah. So it actually has to start here because we're making an assumption that 1068781. 1068781. Okay. The earliest timestamp that matches. Okay, so now let's try. So that works with our sample input. I'm actually curious. 781. How long does it take to get to 7? Decently fast. Okay. So let's try. Let's try new input. And the answer to this one is supposed to be what? 3417. 3417. And the answer to this one is supposed to be 754018. I think our thing's working. This feels pretty good. Okay, we don't need that anymore because we got part 1. We don't need our notes anymore. Well, famous last words. Let's try with our real input, starting at 0. Let's see how long it takes. CPU usage is now high. See, this is what I was afraid of. With so many bus IDs in your list, surely the actual earliest timestamp will be larger than a bajillion. I'm actually curious, what's my earliest? It's 13. One, 2, 3, 4. Okay, let's stop really quick. Let's start here. Okay, I think that's the earliest. We're going to assert really quick that first that current time mod first bus ID equals 0. If it's not, then the whole algorithm falls apart. What is that number? 1, let's see, 1,000, millions, trillions, 100 billion. Yeah. What is the earliest timestamp such that all of the listed? So this is what makes me think that like there's got to be an actual better way to stride through these. And we kind of knew that, right? But at least what we've got a solution that we know sort of works. Is there like a lowest number with mod equal to value? Like, like there's got to be some way of actually calculating each of these, because the way that it's having us do it, like we'll never get there. And this is a thing where like I actually like, I don't know that I could reason my way through this necessarily, because looking at the input, like it's cool that we have something that works. But like what are we at this point? We are at let's go PO. What are we at current time? Yeah, sitting here this long, we've gone through like 200 million operations, and there's no telling how many more we have to go. So there's got to be another way. I just don't know what I'm searching for. Like, is there something about that number that, I mean, besides obviously like the modulus thing, but like, is there something about this number that we could reason about? Or all of these numbers? I mean, this feels dumb, but like, what is 7 times 13 times 59 times 31 times 19? Yeah, that's like triple the number that we actually need. What about that? What about, this is just me like guessing, since we're sitting here and I don't know what to Google for. So, okay, so it's like more or less triple the correct answer. What if I do, instead of doing 59, I do 58, 57, and then instead of doing 31, I do 30, 29, 28. 28. And then instead of doing 19, I go 7. What am I even aiming for? Instead of 19, I go 18, 17. So like normalize the values a little bit. That doesn't really get us anywhere either. Is this like, what if I completely normalize all the data? So this becomes 12, this becomes 6, this becomes 7, this becomes 16. Is this like a least common denominator problem? So like the least common denominator between between 7, 12, and what is this, 58, 57, 56, 55. Least common denominator calculator. Um, 57, 50, or 58, 57, 56, 55. So the least common denominator between, let's write these down. I just did 50, 55. But it should be 7, 13, uh, 7, 12, minus 1, 4, 55, 1, 2, 3, 4, 6, minus 6, 25, and 7 is 12. Okay, least common denominator between these numbers. Is there not a least common denominator? Oh, least common multiple? No. Well, what are those numbers actually multiplied together? Maybe that is useful? Like, that is, there's another 12 in there. I mean, 13, 8, 6. Not really. There's some pattern here. I have no idea what it was. Okay, so at this point, I'm just gonna look because like I don't actually know what to Google for, and it feels like kind of a waste of time to just have you sit here on a video and try to figure out like what to Google for, because there's clearly like some smart equation here, and I don't know what it is. I don't even know what to search for. Part 2. Components separated by new lines. Split on the comma. Doing all of that. Okay. Index equals 1. T equals ink. Where did ink come from? Oh, it's just the bus ID. Yep. While index is less than IDs.count, T plus index okay, T plus the index. So the time, which would be like, you know, let's say 7 plus 1 is 8. Mod the number equals 0, else go up by the increment, which is literally like the same thing we're doing. But the math on part 2 took me about an hour with pen and paper to figure out. But I don't understand, like this doesn't seem like it would work, right? So here, let's stop mine here. Let's comment out my solution and then find out like what's actually going wrong here. Yuck. And then we're going to print t instead of return it, and then oh, I pulled out his parsing. IDs is what? Just makes it equal to 1. Which is like fine, I guess. Okay. Let's keep his answer as wholesale as possible, and then we'll see if it actually is any faster than mine at finding this answer. Or maybe I just don't understand his code, which seems like pretty likely. Let's see. I just want input. Okay, so I actually just don't understand his code then. Okay. So what is this? T is 13, because that's our first thing. And our index is 1, because it just always starts at 1. So T plus index, so 14. IDs sub-index, which is 13. And the increment is 13, so jump to the next. So basically find a number where, like, this is increment times equals 13. Like, you can start skipping ahead. I don't understand this actually. Like, why is INC not updating? What? T is 26. T is 52. 65. 78. 91, 104. I actually don't. I'm gonna switch back to the shorter input that I actually know the numbers for, so I can maybe try to like reason about this better. Seven. So T plus equals increment. I don't understand what this. Well, I get what this is doing, right? This is saying, okay, is the current time plus the current index, so does it line up, right? And then mod it if it lines up. But I don't understand why you can multiply and why you can reset the index. Like it just keeps going through the index and like looking for the next biggest thing. Okay, so starting out, this is our first pass through. Index is 1. Clearly index is just meant to keep track of this, so I don't worry that much about it, other than index kind of tells you what the offset is. Index is 1. T is 7 because it's the first number, so that's how much you increment by. T is the current time, so just step up by the current increment. Okay, fine. Index is still 1, so don't increment the index. $17.21 until what? So we're basically this half. Okay, so it goes 11 iterations to hit 77. Then T, 77, 78. So index. So 78 plus 77 plus 1 is index is 78, modded by ID's subindex, which is 1, which is 7. ID is is 13. 77 mod 13 is 12. But 76 what? Okay, we haven't done anything yet. That is 0. C plus index is 78. Oh, whoops. That's why. There it is. 78 mod 13. So basically we are counting up by increments of the first number until we hit something that is mod 0 of the second number. And then we keep going by increments of the second number until we find something that mods for the third number. So basically he is doing the same thing, right? Like he is counting up, but rather than always counting by that value, okay, so the difference here is that he's assigning numbers that don't exist to the value of 1. And that's not what I was doing. And that's probably going to be a problem. So like, it's like we get to this, right? These are just increment by 1, and go on. So I don't know that mine will actually work. Okay, so clearly it's doable starting at 0, so we don't have to take their little hint. And then what we're gonna do here is we're gonna say, okay, fine, let's do it normal. Let's do it his way, because clearly that matters. We get the same information, but now we have the ones mixed in. Okay, so now we have the bus times, and then that first bus equals bus times dot first. And then what does he start the current time at? He starts it at the increment. Okay, fine. Current bus time being inspected. Bus time to match equals bus time to match, and then current time mod bus time to match. They're equal to each other. Okay. So then what he was doing is saying, go through each number. He started at 1, or an index. Oh, interesting. So he's using a variable index. So basically what we want to do is say, okay, because you don't want to move on. You want to like keep checking that same index. So what you're trying to do is you're basically checking and you're saying, okay, like let's keep counting up until we have a number that works for this number. So I guess what I was going to do is say for I in 1 through bus times dot count, and then do yep, that's fine. So this gets us the bus ID we're looking at right now, and what we're trying to say is does, I'm going to go to up till -1. This is next bus ID, and then we're going to say while current time mod next bus ID does not equal 0, current time equals plus equals current plus equals bus. This is its current bus. Current time plus equals current bus. And we keep doing that until we find one that matches. And then we do bus, and then we let just I increment like normal. And then we print the current time. I think that's the same thing that he just did. We're gonna do both here. Oh, current bus never got updated. Whoops. So current bus equals bus times sub I. Is that right? I think that's right. This is weird that we're always doing I plus 1. It's probably a smarter way to do that. Yeah, this loop is still not doing exactly what I want. Start the current bus, do the thing. I guess we can just start at 0, and this is, we can just do like current bus equals bus times sub I, and then next bus equals this one, and then current time. Let's try that. Still not right. What am I doing different here? Current bus is 7. Next bus is 13. And then actually want to know. So what do we land on first? 91. Uh, 91 mod 7 mod 13. Okay. Current bus is and then current time, not current time. No, we got the increment right. Equals bus times dot first. So we start at the time of the first bus. What I want to do here is every time I want to print the T. Yeah, so he stops at 77, not 91. But 77 mod 13 isn't right. But 78 is. Interesting. Why does that work? Why does 77 work, but like, why are you stopping one early? Like that feels weird to me, because like the way that the logic is set up, like I think that's basically that. 77, 77, 7. And then he gets to 350. Okay. Because this video is running long, I'm gonna pause and like see if I can figure out the logic on this and then come back to you later. So thanks for sticking around so long. This is a really weird one. Okay, bye. Why does that work? get that. Time the target time is 78. Then because we just 77 plus 1 is 78. So this one, so the one out of this slot has to be 78. The next bus is 13. 13 is the one that's trying to match this next time. And then target, so target time, so the current time is 77, it meets that, which is 78. Which meets that requirement. Okay, and then once we find a target time that the next bus meets that, then our increment 7 gets multiplied by the next bus. It's 13, which is 91. 91 mod 7. Increment by the next bus. So basically what we've done is we've counted up and we found that, but we know that every number after this has to increment by that value because, okay, so let's do this. So it is 7, 13, 1, 1, 59, 1, 31, 19. So it starts at plus 0, plus 1, 2, 3, 4, 5, 6, 7. Okay, so the smallest number we count is 77. The smallest number was 77 plus 1. 77 plus 1. 77 plus 1 mod by 13. equals 0. Equals 0. What? Oh, because I'm using the old input. That's fine. My real input is what? Okay. So then this one is um, 77 plus 1. The number you're trying to hit is growing. What the hell? $77, $77, $77. Current time is 1:14. $1:14 plus 3 plus 1 modified by 59 with 0. I don't understand. Oh. Then you do okay. Then we do increment, and then it's time increment times equals current bus. Is that right? $63. I think it's just plus I actually. Plus I. Jeez, I'm so far off. I need to actually do his first. So I can actually see the outputs and compare. So 77, 77, 77, 350, 350, 70147 twice. Oh. I'll go through the best times.